Okay, so on with the presentation. So we're all familiar with Yocto and we can build images. Yocto is wonderful for that. But how do we test those images? So when I first started, basically I would build an image and then burn it onto the device and test it. But being the older guy around and working with lots of younger people, they all seem to use GitLab for everything in the world. So I've learned enough about GitLab and was able to automate that process so I could build the image, and now I've added installing and testing it as well. So this is a little diagram of basically what this presentation is going to be about, how we can use GitLab to build an image, push it onto a device, and test it. So there's not too much required, but I always wanted to mention that. The recipe we need here, we need a Yocto build environment. I assume you have that. I'm not going to cover any of that. We do need a target device to test this on. And of course, you'll need a GitLab account. And then you'll need a host machine. I use my laptop for most of my builds, but you'll actually probably want a separate dedicated machine, more like a server that's on 24/7. And the reason for this is basically the whole concept is that anytime you update the code at all, that it automatically triggers a build and then an install and a test. And if you want that full functionality, then you'll want something that's online 24/7, not just when your laptop's open. And then you'll need to write just a few lines of code to put this all together, and I'll basically step you through some of the basics and give you a high level of what you'll need to do to set that up. So if you're not familiar with GitLab, most people are familiar with Git, and then there was GitHub, which is a platform, and then GitLab came along, I believe, sometime a little bit later, and GitLab, in my view, is just an enhanced version where they've added a lot of extra stuff to Git. And that's what I'm going to basically present here, some of the extra stuff. But if you want to learn about GitLab specifically, you can follow that link. It's rather lengthy, but the first few minutes will explain GitLab. So the first thing that we'll do is create a blank project. So this should all be very familiar. This is basically the same as you would do in GitHub. And then from the blank project, you can clone that. So we'll clone that onto your host machine. So this is all basic Git stuff here. And then once I have that project cloned, I can put my Yocto build environment there. So you can see I have my build and my sources directory of very basic Yocto setup. And then you should commit and push this back to GitLab. So you'll see here my status that I'm up to date and the working tree is clean. So the next thing, that's all pretty basic. The next thing that you'll need is what is called a GitLab runner. And in my own words, the GitLab runner is basically a server that GitLab can send build jobs to. So there's links here. GitLab has quite a bit of pretty good documentation to figure all this out. You will need to figure out how to install the GitLab runner on a machine, but it's very easy to set up. It can run on different platforms, Windows or that. We'll be running it on Linux here. And there are several options for the what they call the executor, I believe. And for that, you'll want a shell executor, which you'll see here and see why we want that. So the next thing when you have the GitLab runner set up is you'll need the GitLab config file. The config file is just a very short, simple file that has all the configuration, including basically the script that the runner will run when it runs a job. It's in a YML, a YAML format, but the nice thing is it will take bash commands in there. So that makes it very easy for those of us that are very good with Linux. So this is an example GitLab YAML file. This is the GitLab config file. This is part of it, but basically, for Hello World, this is basically enough to get you started. You do need to tell it what stage you're on, and we'll talk more about stages later. The important part here is the script, which these are all just bash commands, and we'll see these run to get started. The last section here is tags, and briefly what tags are a way of connecting build jobs to GitLab runners. So I can have multiple Git repos that may share a runner, or I may have multiple runners for one repo. So if I have multiple runners, it will try to send the job to one runner, but if that runner's busy, it will send it to another. So the tags are just basically a way to connect the runners with the jobs. By the way, I should be going back and checking the Zoom here to see if anybody's posted any questions, but
there are no questions yet.
Okay, great. That's good. Now, if I can get back to the slideshow. Okay. So when you set up this GitLab config file, then you can start the pipeline. I can show you how to start that manually. But basically, any updates, any pushes to the repo will cause an automatic run of the pipeline. So just updating the GitLab config, which is in the repo, it's as a dot file, so it's hidden, will trigger this build. So there is a way to get to this. You click on CI/CD and go to jobs, and you'll see all the jobs and the history of those. If you click on the job number here, I don't know if you can see my cursor, but this is actually a link. And when you click on the job number, it will actually show you the log file of that job. So here we can see the example ran. It fetched our Git repository, and then it executed our script. So we can see it did our hello world. I put these others in here just to comment on a few things. The Git status, this is slightly different than you would see if you just pulled it yourself and had a checkout. The status is a detached head, and that there's a reason for that. I had to work around that because I had a reason why I didn't want a detached head, and only to eventually learn why you really do want a detached head. But I just wanted to comment that it's detached because the expectation is you'll make no changes whatsoever to the Git repo in this job. And if you do, you've just invented recursion, because any change to the repo causes another job to run, which that job's probably going to change the repo again. So that's basically why the status is detached. I did who am I because previously on earlier versions of GitLab, the GitLab runner, it would always run as root, which Yocto doesn't like to run as root. So I had to switch users. They finally updated that, and now the jobs run as GitLab runner. I did a PWD here, so you can see basically there's a long path where this is actually run. GitLab has a lot of built-in variables, so you can actually get a variable to tell you where this job is being run on the machine if you need to find it. So GitLab, one of the really nice things is this is pretty well developed. I know there's a lot of other options out there that will do similar things, but I've been pretty happy with GitLab, haven't had too many complaints. They have pretty good documentations and loads of features and flexibility. So the default setup is that the jobs run every time there is a commit. But some of these jobs can be kind of long, so you may not want that running every time you fix a typo or something. So there are other ways you can configure it. I'm not going to go over those, but I'll just mention those. You can have it run on the main branch only, which is nice if you're doing work in a separate branch that you'll eventually merge back into main, so that while you're working on the sub branch, you're not running lots and lots of jobs. One of the things that I've switched to recently is I have a quick check run on every commit, but I have only deploy and test run on tagged commits. So I can use tags to basically mark where I have, working code, things I want to release to other people. You can also set up to run manually, as well as that's always available from the web interface. You can trigger a pipeline run, either the whole pipeline or specific jobs in the pipeline. GitLab has flexibility that I work on a team at my job, and I do the embedded Linux, but there are other teams that do the computer vision and some of the web stuff, and they have Git repos, so we can actually link those Git repos together so that if they publish a new version of the computer vision, I can automatically spawn a build and build an image with their latest stuff included. And of course, GitLab has the ability to pass variables into the pipeline, which is very, very useful. So I showed you basically the hello world. So now I'll show you how to actually use it to build an image. So there's multiple ways to do this, but the way that I like to do it is to write a basic simple build script. I think most people usually have something like this in their Yocto setup. So I have a script here that just does the basic setup. I always like to do a clean. I use clean state, and that's just to be extra safe to clean out any previous images that were built. And then I bake a new image. I do like to use the -K, especially at the beginning, so that it continues in case there are failures. So here we can see I've updated the GitLab config. Here we can see I've updated the GitLab config. So instead of hello world, now we're going to run that script. Why is it changing here? Sorry, having technical difficulties. Okay. So now the script is going to run that shell script I showed you to bake the image. There are a few variables I put here, and I'll explain those. These are basically to improve the speed of your Git job. By default, GitLab does what is called a Git clone, and the Git clone will basically make sure that it starts from a completely scratch. And starting completely from scratch is not really what you want, because then it will be fetching everything and it won't have the S state and things like that. So there are flags here that I have that basically allows you to put a git ignore, and you can ignore things like your S state or your downloads, so those won't get cleaned out. There's another improvement to switch the strategy from clone to fetch so that it will just get updates, not reclone the entire repo. And when you're doing fetch, you can set the depth. This is probably a minor thing, but since we're not going back in the Git log or the Git history, we can set our Git depth to 0 so that it just gets the latest. So now I've basically run with that updated Git config. And you can see here, this is the typical ending of a bit bake, and the job succeeded. So now with that Git config in place, we have the first level of automation, which is any updates to our Git repo, to our Yocto, will now cause an automatic build of the image. And we can check and see how these builds came out. So we can see a typical snapshot of some of my real work here. And you can see I was fixing some make file down somewhere in the Yocto build. And I had 2 jobs that failed, but the most recent one was successful. So on the one hand, you might say, well, why didn't you check the make file before you checked it in? But basically, the whole point of this is to set this automated GitLab up so that I don't have to check it, that I can let GitLab check it for me. So I can check in what I think will work and go off and get a coffee and talk to coworkers and then come back and then just check the status. And then I can see, oh, I got a green check, it passed, great. Or I can see, oops, that didn't work as well as I thought it should. And then I'll have to click on that and go look at the log and see what I did wrong and fix it. So basically, I've broken this into 3 discrete stages. The nomenclature for GitLab is they call the whole thing a pipeline, and then the pipeline has stages in there. So you can set this up any way you want. You could have just one stage that does the build, the deploy, and the test, or you could set it up to have a build and a deploy test stage, or you can set it up this way, which is basically how I kind of like things running, is to set it up in 3 stages. So the build is just what we saw, depending on how fast your machine is and so on, will take a few minutes, hopefully. The deploy, that actually takes quite a bit, approximately 15 or 20 minutes, just because it's downloading a rather large image to a remote embedded device. And then the test phase, will basically depend on how involved your testing is. But the test phase I have here, and I'll show here, is just pretty lightweight, but you can obviously make that as detailed as you need. So when you put the stages in place, GitLab has some predefined default stages, and their typical default is shown here in the documentation. They have a build, a test, and deploy. And the reason they do testing before deploying is that most code is set up to basically be runnable on the host machine. But since we're doing embedded development here, the host machine isn't the same architecture as our embedded machine. So the stages that I showed are actually reversed, where we'll do a build and then we'll deploy to the target architecture, and we'll actually be testing on the target architecture. So GitLab allows you to change those defaults very easily. This is the syntax you would put in your GitLab config. And at the top here, I've defined the stages as build, deploy, and test. So that's the order they will be run in the pipeline. So you can see the build job as we had before. We'll run our little shell script to bake the image. And then here I've got just basically some examples of what we would put in our deploy and our test job. So now with that in place, when we run the pipeline view will show three little stages here. And this is not live, this is a PowerPoint slide, but if you hover over each of these, you can see the names of these stages, which will be build, deploy, and test. And you can see the status of the pipeline. This is just a screenshot here, but you can see which stage is running. You can see whether they got the green check or the X. You can configure it to allow failure is another option. So you may have situations where you want to allow failure, and I think it has another color if it fails, but you allow failure. Allow failure means if that stage fails to not quit the whole pipeline, but to go on to the next stage. So I've put a slide here with a typical example of what would be a very simple deploy job. There's very many different ways you could skin this cat and do this task, but this is an example here. I've set up the target IP of my remote device, and I'll be using a SSH method to push this image to that target device. So instead of using a username and password, I'm using an SSH key that's stored here on the host machine. I've told it the file name that I'll be pushing to that device, and then the path where I can find that. And oh, I see I have a typo, a double slash. That should be a single / there. You can see I'm using one of the GitLab variables, CI projector, which was like you saw earlier where I did a PWD. There's a long path where this job is running. And then in your typical Yocto setup, it would be in build, temp, deploy images, and your architecture, and then that file name. So the script here, I put some echoes. So if you do look in the log, you can see what's going on. And the first thing we do is a SCP, which is a secure copy, basically an SSH copy. And we're going to copy that image file to a specific directory on our target machine. Once that's installed, basically anyone that's doing development for remote hosts usually has some sort of method of a live update or an OTA update. Here I have, just an example, since we have SSH access to our remote machine and we've just pushed the image, I can run this little script called install image and install the file name. Now, one comment here on the deploy job, typically once the image is installed, you'll need to do some sort of reboot. And a reboot would basically cause this job to fail. So everything in the stage in the script is blocking. So it will wait for completion. And if your script basically does a reboot, it won't ever see the completion. So here we would typically have the script complete and then reboot, or you'll basically have to do some finagling if you want this job to pass. but be rebooting. And that's one of the reasons why I separated out the deploy and the test job, because there is actually a reboot in between the deploy and the test job.
2-minute warning.
Okay, I think I'm pretty good on time then. So as my example showed, I'm using SSH, but you could use many other methods to deploy your image. You should probably do a lot of verification, make sure everything's good, and you may need to configure something before rebooting. The test job is basically once the machine has had that image installed and it's back up and running, then you'll just basically, in this case, SSH into it and run your test script. So here I have just a very lightweight example to show you how it could be done. I have one called check version, which just tells me what version is running. So I would, in the script, basically verify that that's the version I'm expecting. So on that, this is my last slide, I believe. You would just basically verify that we booted, that we're running the new image, not the old one. And then you're, on an embedded device, you may want to verify that all your peripherals are working or whatever your normal self-test would be. So I think I'm about out of time here. I'll see if there's any questions. But I hope you enjoyed this. If not, then I'll work on a better presentation next time. This is my first presentation at the Yocto Summit. Please contact me, connect with me on LinkedIn, Clay Timmons. And if you're ever in the Dallas area, I always love talking to fellow Yoctonians, so look me up.